Welcome to another episode of Connecting the Lines. Today's electric utilities face a complex set of challenges that continually threaten the resilience of the electrical grid. There's extreme weather events, aging infrastructure, population growth, and just the overall ever-increasing demand for electricity. New technologies like AI, something that didn't even exist in the mainstream just a few years ago, require a ton of energy to operate. One recent study found that U.S. Bitcoin miners, a super small portion of the population and economy, now use as much electricity as the whole state of Utah. But utilities are fighting back. To combat all these challenges, the industry and governments around the world are focusing on upgrading existing transmission and distribution infrastructure, expanding capacity, and deploying new technologies as they work to harden the grid. But what exactly is grid hardening? What specific areas should utilities focus on? And can an electrical grid ever truly be completely stormproof? Joining me to discuss these topics are two people who have a wealth of engineering and product design experience in the electric utility industry. We have Mark Burns, market manager for distribution products, over 30 years of experience in the electric utility industry, member of NEMA, including the committee chair for high voltage insulator standards, and part of the Utility Products Leadership Committee. Authored multiple papers covering conductor repair, named on 6 patents, I believe that's correct.
Mm-hmm. Yep.
And I have a degree in electronic engineering technology from the University of Akron. Go Zips. Ken Akiki, market manager for transmission products. 10 years of experience in the power transmission industry with a focus on conductor motion mitigation, active member of IEEE and CGRE, and bachelor's and master's degree in engineering from Case Western Reserve University.
That's right. Go Spartans.
So let's get right into it. So when we talk about grid hardening, also called system hardening or storm hardening, what are we referring to?
Well, it really depends, I think, a little bit on who you ask at the utility and a little bit on who you ask here. From a utility standpoint, you know, they're wanting to make their grid resilient against any type of climatic force or even outside of climatic forces, just heavy load. So, you know, if you're down in Florida, you know, where you see a lot of hurricanes, they're going to try to make the line resilient against hurricanes, specifically wind load being the key factor, you know, there. If you go to Iowa, where you see not hurricanes but ice and wind loads, then they're making the structures and the conductor of the hardware resilient to those types of loads. But from an overarching standpoint, at least from a transmission standpoint, you know, system hardening is making your system resilient against abnormal operating conditions.
Okay, that's great. Mark, anything different?
I concur with all that. That's for sure. On a distribution level, you know, obviously there's a lot more distribution poles. There's a lot more exposure. We're down, you know, the structures are shorter, so we have to worry more about tree damage and things of that nature. So to what Ken said, in a distribution environment, they're using larger poles, using double cross arms. When we look at what preform supplies, they'll look at you know, severe weather tie kits, which bundle, you know, conductor protection with a form wire tie. In corrosive environments, hardening the grid means using materials that are less likely to corrode and fail in a shorter period of time. Hardening the grid includes reinforcing current existing splices. So we have, you know, there's products out there to ensure that a splice, because conductor is not going to be continuous from point A to point B, you have to splice it, and a splice is always one of those spots that is prone to failure. And so there's products out there that can be applied to existing splices to ensure that it's no longer a weak link. But going further, especially in my role in NEMA and the Grid Leadership Committee, grid hardening is taking on a huge definition that includes everything from the structures to actually the movement of electrons in the system. So there's a big push to integrate in the green energies, the solar, the wind, and use that as a part of grid hardening, but also have the standard or the current or the fossil fuel type of generation as well, and then integrating all these together to reinforce the grid and make sure it is much more resilient. So resiliency, in my mind, and what I've seen, especially in the last year, is resiliency is being more a key word in hardening than just structure reinforcement. So there's a lot more that you have to look at, and preform is starting to play a much bigger role in a lot of those areas, even in the green energy position as well.
Is what we're talking about a lot due to aging infrastructure? Is that what we're talking about here, like replacing aging infrastructure?
So yeah, I mean, aging infrastructure is absolutely a huge factor. I think I saw a quote on LinkedIn the other day. I can't remember who said it, but basically that if Thomas Edison were to come back to life suddenly and look at our grid, he'd be like, especially from a infrastructure standpoint, the material standpoint, like, wow, guys haven't really done much, huh? We look around here, in Cleveland, Ohio. A lot of the infrastructure is, if you know what you're looking at, you'll say, wow, this stuff has really not been touched in quite a while, just from a material standpoint.
Right. Well, in case in point, one of our ex-employees, Bob Wampam, had a big hand in the design of the line that goes down 480.
Yeah.
So you're looking at, 35 years ago when he designed that line, it was built. So, and that's a young line.
Yeah.
So you're absolutely right. The aging of the infrastructure is critical, and is clear when you see a lot of the distribution lines. You drive around, you see old utility poles, and down guys and loose down guys. All that system, a majority of it, predates me. So me being a young guy like I am, it's not that old, I guess. But it goes to the point that you can't replace everything at one time. And what the utilities are doing, and this is some of the things we're seeing, is they're taking chunk by chunk. Ken's seeing a lot of it in the transmission side because obviously you want to reinforce that piece first. That's the biggest piece, and it can affect the most people when it goes out.
Right.
But I'm seeing on the distribution side, especially when a storm like Hurricane Sandy came through, over a decade ago, the government pushed a lot of money into that. And you look through New Jersey and Long Island, and they reinforced that system substantially right after Sandy. So if you drive through that area, you'll see much larger poles. The poles are you can see they all look relatively new. They're in good shape. So in areas that happens, all of a sudden you'll see a big, huge increase in funds, and then you'll see a rebuild quickly. The tornadoes just recently in Texas, another piece. We're seeing a lot of money being focused in that area for storm hardening.
Yeah. In fact, talking about the aging infrastructure, one of the numbers that I got was, according to the Department of Energy, nearly 70% of the U.S. grid is more than 25 years old, which goes along with what you guys are saying, and sometimes substantially more.
Yeah. I mean, the common refrain at any utility I talk to for transmission and line is they want to target 50 years. 50 years is a good number, right? It's like, okay, we can keep this transmission line operating for 50 years. It's made its money. You've got the payback. But the fact of the matter is there are a lot of transmission lines that are a good deal older than that, 67, pushing 70 years old, World War II era transmission lines. And I think you see that even more in distribution.
Well, in distribution, and it is a funny thing because you can look at a distribution line and get a good idea of its age by looking at the conductor they're using. A case in point is, and it's surprising how much material we sell for this, copper conductor. Oh, yeah. Copper conductor has not been sold since the 50s for actual applications in the field. And so when we get requests or you're driving down the road and you see an old green-looking conductor, well, that's copper. That's an old line. You're looking at something circa 1950 or older.
Yeah.
So what about new construction? Are we doing enough? Are utilities doing enough on new construction to, build things to appropriate measures to combat this?
So I think from a transmission planning standpoint, in terms of like new line builds, maybe. There are a lot of potential projects out there right now. I think it's even becoming like kind of public knowledge right now that we don't have enough generation and we don't have enough transmission backbone behind that generation to really support all of the kind of initiatives that are going on right now. Green initiatives, but no matter what you feel about them, electric vehicles, renewables, they are happening.
Right, they're here.
They are here. Onshoring of manufacturing. I just was reading a really interesting story the other day. Intel is building Intel is building a huge plant in North Albany, Ohio. They're taking some of these, they call them mega loads from Cincinnati, the Ohio River,
Yeah, I saw
up
this
to
as well.
yeah. It's Ohio. They're literally having to bury portions of transmission lines and distribution lines, crossings over roads to be able to
get it through.
So like, there's one aspect, but they're building literally 2 brand new transmission lines just to fuel that
one.
that load. So I mean, and that's great. That's American jobs. That's fantastic. But so from a planning standpoint, yes, I do think that there's the plan and the realization around like, hey, we need to be doing more. From a technology standpoint, though, this is the other big thing I've been reading about. I don't think so, and I think a lot of it comes down to risk. There are a number of advanced conductors, composite core conductors out in the industry that have been developed for, since 1999 now. I think the first one came out. 3M released the first one with ACCR. They have a less than 1%, less than 1/10 of a percent of market share because of how different it is to install and how, well, frankly, how expensive it is compared to regular conductor. And you don't see utilities wanting to take risks in using these advanced technologies, especially on the larger, longer, say 500 kV transmission line. But really, that's where you're going to get the biggest bang for your buck is if you really use these advanced technologies.
Something to reduce the resistance of the current carrying members.
Yeah.
What's going to save you money in the long run. But I might have a slight disagreement with Ken. The utilities are planning and they're doing things in the transmission system for that piece, but they're not looking at the technologies in conductor. They're more looking at the electronics. That is got all the pizzazz and it's got all the wow factor that they can take to Congress and get policy written. So the Snyder Electrics and the Eatons and those guys have a lot of these different pieces of equipment that can help current flows and with distributed energy resources or DERs, they're working on those from a resiliency or backbone standpoint. So that they kind of steer away from the conductor and until we can convince, or the manufacturers of conductors and hardware can convince, look, companies, you need to plan for this as well because this is coming down the road and it's going to help you over here. The planning, getting back to the question, the planning on the distribution side is woefully inadequate. There are utilities that have eyes on different sections of line, but there's a lot of things that push what gets done in a utilities system from a rebuild of distribution assets. Obviously, those are load growth. Their politics is involved as well because it's always that thing's always on the outside, and it's where's the money going to come from? So there's a lot of things being done through policy, talking to Congress to try to get money for rebuilding systems, but to my knowledge, I'm not seeing a lot of the distribution side being addressed in any of that policy. I think their expectation is that once the transmission piece is fixed, that policy will leak down to the distribution side, but also there's also regulations requiring the way utilities deliver energy to the end customer, and then they rely on that to help build out that system. But again, I still think it's woefully inadequate, the planning that is in place for rebuilding of distribution assets.
So you mentioned, the monies out there, or that there is some, and there's the Infrastructure Investment and Jobs Act. So that is, an active money that is out there. I think there's other ones from state programs, and some utilities are doing this on their own.
A lot of private money too.
Yeah.
Tons. And transmission.
Where should that money go? Like, what is the critical needs that you see?
Well, load centers are growing. As Ken's pointing out, you have some of these big companies coming in trying to reshore. And when they reshore massive resources, it has a huge energy draw. So, cities are, there's a lot of cities out there looking at this and trying to get utilities to provide power to attract these people. Mm-hmm. But in the long run, you can't lose sight of everybody. You can't make a choice to worry about these customers and not worry about these, because at some point you're not going to have power for these customers. So going back, planning is critical. I believe there needs to be monies put out to really have a good idea of how these circuits, how these distribution systems are working. My background when I was at Ohio Edison was in capacity planning, and it was a really interesting job to understand how different loads affect the grid. When we start throwing in distributed energy resources, green energy, wind turbines and solar, that really messes up a lot of this planning, because now you have flows in the circuit. Circuit flows were from generation, transmission, distribution to the end customer. Now it's not. Mm-hmm. Now you can have flows backwards. And so that's, again, I go back to the electronics guys. That's why they're getting a lot of buzz.
Right.
But it does have an impact on how the utility can plan and build out those systems to ensure resiliency for your end customer.
Mm-hmm. So, Ken, what about on the transmission side? Is there specific areas that you think should be a focus?
So I'll say first the areas where I have seen, where I've currently seen a lot of focus, and that is in, heavy population centers. There's no surprise that, like Los Angeles, Southern California, because it's much more than Los Angeles,
Chicago
is growing, continues to grow, and every major transmission line that I've been part of over the last couple of years basically eventually ties back to Southern California, and even kind of extends as far out as Vegas. We're seeing a lot of concentration in, especially from a private equity standpoint, in population centers. They're seeing that they're going to be able to get their payback in private equity faster, because they are being able to bill the managing utility more money, because they're seeing the number of rate users, the number of meters that line is affecting. Mm-hmm. And so then they just see the dollar signs. They're literally debt financing these lines around the promise of basically continued growth. Now, there's a lot of questions on if that is something that they should be is morally appropriate, but we won't get into that. The big challenge about transmission is big, and a lot of the opposition we have seen in transmission build over the years has been a lot of these not in my backyard type I shouldn't say policies, just people, mm-hmm. Which and so
they don't want infrastructure.
Exactly. Yeah. Okay. Farmers don't want a transmission.
We'll just put it underground.
Yeah. Put it underground. Yeah, except
I have a question on that, but we'll get to that.
It's an interesting answer. But transmission is the most effective, or transmission makes the most sense when you're transporting energy over very long distances. And when you do that, you're inevitably going to be going through communities, through farm fields, through whatever. There's been a lot of opposition to that. There's been some government initiatives to help with those programs to basically streamline route approvals, basically compensate individuals or communities that are being affected by these builds, and the promise of jobs, basically local jobs, to help build this. Mm-hmm. So we're seeing more kind of cross-country interconnects. As well, basically connecting portions of the grid to other portions of the grid so that power can be bought and sold in an easier manner. It's a highway. Electricity is a highway. You're trying to direct it towards the most optimal path possible. And that with promises basically that that is going to help keep electricity costs low because you can buy from the cheapest generating source at any given time. Mm-hmm. So that's where we have been seeing things, and that's I think where we're going to continue to see transmission to go is basically being able to try to generate cheaper or transmit cheaper electricity and also connect up to renewables.
Are there system failures that are foreseeable? So I guess is there obvious weak spots within there that that there's going to be an issue that could be easily preventable?
So from a mechanic standpoint, if we want to get in the weeds a little bit, yes, a lot of these modern transmission line boats, especially when we're talking about HVDC, which we could talk about maybe a little bit more detail here later. That's high voltage direct current. Are using very, very large conductors in a large conductor bundle to be able to transmit just more electricity. The problem with that is that's all well and good, but the conductor motion mitigation of that large of a conductor in a bundle hasn't really been something that's been looked at very, very much. We're basically trying to use conventional applications of spacer dampers and the conductors to mitigate vibration. But we've done some kind of preliminary analysis and research and kind of saying, may need a little bit more than that to really mitigate the wind-induced vibration on conductors that big. It's not quite as simple.
Okay. What about on the distribution side? Is there obvious things?
Motion is always an issue on every system, and we've proven over the last 60 years that if you don't take care of motion, conductor motion, and all conductors in the environment are going to move, it's going to result in damage. And it is
the number one mode of conductor failure.
Yeah, and it's something easily addressed at the point you build it. And we've proven this over decades. The other piece is, and I referenced it earlier, is splices. Those are known joints. They're going to degrade over time. And so there are ways to address them and reinforce them, harden the system, and that will be taken care of. Our friends at PG&E did that across their entire 500 kV system. And to date, I don't know if they've ever had a failure in any of those splices. So there's a lot of other places on the distribution. There's a lot of touches. There's a lot of equipment. There's so many more pieces of equipment than there are on the transmission line that actually interact with the conductor and transformers and capacitors and arresters and the whole 9 yards. There's a lot of things that a utility can do to look at these things and understand where the failures are going to happen, and they are always usually the connections, the connection points. Hardware and electronic equipment and things of that nature will fail over time. It's going to happen. But you don't know. You can't address those things. But connections, you can. Everybody knows. You make a good connection the first day, it's going to be a better system throughout. And that's one thing we try to train when we're talking to linemen. You got to make that connection right the first time.
So what is the most complicated issue to fix that just may never be able to be completely 100% fail-proof or anything like that?
From a distribution standpoint, it usually ends up with the structure. What kind of structures are you using?
The poles or yeah.
And you can't control, if you're using wood poles, you can't control rot because you don't know what you're putting it in, right? Silty soils will tend to destroy a pole quickly because you have all kinds of active material around the base of it. And utilities aren't going to go and use composite poles everywhere. You've got concrete and spun. You got spun concrete. You've got ductile iron. You've got fiberglass poles. There's a big cost adder to do that, and wood poles are still very, very cost effective. So that's one thing they'll never get away from. And then you have car pole accidents and things of that nature that you cannot control.
Right.
So there's a lot of things that they're never going to be able to fix, and you can't plan on it.
What about a transmission side? Is there something that's just very complicated?
I think one of the things that makes building transmission lines so complicated is that they're really expensive. As compared, not to take away from distribution on Mark's side, but transmission lines are just enormous pieces of investment.
Is that just the planning, the engineering behind it?
All of it, yeah. All of it.
Well, I think a big piece is the route.
That's
Spending the money just to get
The right of way?
the right
yeah,
of
the
way
right of way,
is
exactly. Yeah, the
ridiculous.
planning of a transmission line from a time standpoint, and time is everything. Especially right now, where our load base is going.
The curve's going up, yeah.
Time is everything, and that's what it's taking the most time, takes the most resources, is route planning. And we've seen entire transmission lines projects be shut down, completely scrapped because the route could not be agreed upon. It was basically deemed too expensive to go around, say, an endangered animal habitat or a community. And so basically the entire plan for a multi-100-mile line was just scrapped.
Wow.
Just put an example. We were looking at a project just earlier today, 240-mile transmission line going between Utah and Nevada. And it was $750 million of a transmission line. And that's a cheap one. It's nothing for a transmission line to be in that multi-billion-dollar factor. So then what you're then seeing is the people building these transmission lines, the contractors building these transmission lines, trying to keep costs down as much as humanly possible. So you start getting nickel and dime, even on a hardware standpoint, where we account for 2.5-3% of the total cost of the project.
Yeah.
You start getting nickel and dimed, and for trying to reduce your cost of material, and you start to sit there and ask yourself, like we're trying to help you keep this incredible investment operating for a while. It's like, why don't you just accept something, a hardened product?
Right.
That is something that we're always going to contend with. The battle in between utility procurement and utility engineering is it's always going to be a battle, and it's going to continue to get worse before it gets better. Because you can have a utility engineer convinced that a hardened solution is the way to go, but then have procurement basically say, nope, we got to cut costs. We're going this way.
Understood. So you mentioned this earlier. So what about underground? Is that possible? Is that you guys laugh?
Underground's
that's distribution.
It's always possible. In distribution, it's used a lot.
In big cities,
My
right?
community.
Well, not even big cities. It's used, for anybody knows distribution. You got primary distribution, which is 7,200 volts and up to 34.5 kV, and then you have your secondary, which is 600 volts and below. 600 volts and below every day. You can put that in the ground, and all new allotments, residential allotments, are always going to have all their secondary buried. It's just the way it is. Primary becomes more difficult, but primary is very variable, especially at the standard voltages of 13.2 kV. That's done in most new allotments as well. So you'll have primary coming in to a transformer on the ground and then to the homes. When you start looking above, even 34.5 and above, now the cables and because now you're using conduit, and and when you really get into the high transmission, you have concrete encased, because you can't have people digging into the stuff. You need to keep the ground plane all of a sudden comes right on top of the conductor, so your insulating materials have to be perfect. So you only are going to see transmission put underground in very rare areas. You're going to see it probably in areas where you have lots of dollars, and the people that own these multi-million-dollar houses don't want to see overhead lines. So it's it can be done. It's just a cost. It's a cost play. So when you look at transmission overhead, it's X.
10 times.
When you go put it underground, 10 times would probably be still a good job. Good.
Yeah, that's the kind of the
distribution. However, your primary distribution underground used to be 5-6 times pole. It's now below 3. So the cost underground is coming way, way down. So primary, it doesn't make sense everywhere still. And, if you're out in a rural area, underground still doesn't make a lot of sense because it's hard to find faults. It's hard to find problems when that conductor's buried. If it's above grade, you can find it,
right? Yeah.
fix it, and then if you have to go out and you've got a break somewhere in the middle of this line, well, you're going to have to dig it up. And those customers are going to be out of service until you get the ground open, you get it spliced, and
Not an easy fix.
Whereas if it's above ground, I can jumper while I'm fixing everything, and these people are back up and running. So underground's realistic on the distribution side by far, and they use a lot of it, and that's the trend. Transmission, I don't ever see that really going underground.
Occasionally, a utility, like we get a new CEO. I'm not going to name names here, but we get a new CEO, and they'll be like, we're going to, really try to keep, transmission lines out of people's eye views. Really try to really harden the system. We're going to put 20% of transmission underground. And we just kind of laugh. Mm-hmm.
Well, it's go ahead.
Yeah, it's like if you have the rate base, sure.
And maybe PLP will have a product for you. But again, it's all going to be, at the end of the day, it's all going to be dollars and cents. And if they can get the money, they'll do it. Mm-hmm. It can be done. If they can't get the money, it's going to be the old way. It is. So.
Right. So let's talk about standards and committees a little bit because you're both involved in NEMA, IEEE, CGRAE. How are they involved in system hardening, or are they?
Oh, they definitely are. Mm-hmm. So it's kind of interesting, and I'll talk on CGRAE first. So CGRAE, one thing to note is not a standards committee at all. They are not writing any technical standards that must be followed, that are adopted by the industry. CGRAE is an international organization. It used to be a French acronym, but now it's just simply CGRAE. And CGRAE is made around writing publications, technical brochures, centered around just the betterment of the utility industry at large. I work in a study committee B2, which is around conductor hardware and system hardening from a material standpoint, and that is all we are concentrating on, is writing technical brochures about materials and hardware that maybe just haven't been kind of talked about as much. So there's a study committee on interface spacers right now, which are products.
There's a study, there's a committee that does wildlife protection.
There is a committee that does wildlife protection.
And you say, okay, well, that's nice. Well, wildlife protection interfaces with transmission in a big way, as well as distribution. Mm-hmm. So, and we have people involved in that as well, and I've been pulled in to help. But that's wildlife protection can also be considered a hardening requirement, because you need to ensure that the system stays energized regardless of what gets on that system.
Yeah. You think that tornadoes and hurricanes are unpredictable. Let the squirrels loose on a distribution line and it's all over.
So we kind of talked about that no matter what you do, there's still going to be storms that come through. There's still going to be outages. There's still going to be, hurricanes. You can't make anything 100%, storm proof. So when those disasters, inevitably happen, what can utilities do to best prepare for that, to best ensure that the power gets back on quickly, or what are they doing, or what can they do?
In a distribution realm, and we do this all the time, especially when hurricanes hit, we have storm material that we know we sell them, and we go out of our way to make sure that we have that prepared regardless of whether the customer knows. Mm-hmm. But, customers do have, especially those in those areas that are prone to hurricanes and tornadoes, they have plans in place to ensure that they can get to their suppliers and get the materials they need. The bread and butter items that they know they're going to need to put that pole back in the ground, guy it, get the conductors on it, and get the power to the next guy. Things we don't deal with are like transformers and switches and capacitor banks. Those are a lot harder to come by. If anybody knows transformers now, you're looking at a year-plus lead time for a standard distribution transformer, which is nothing. Mm-hmm. Imagine a substation transformer. So they have to think way ahead about how they're going to get material in the case of a hurricane, to that point, they know that suppliers can't have everything at readily available, and they can't stock everything.
Right.
So they have agreements with neighboring utilities as well as utilities across the country
resources.
to share resources, to share manpower, to put these things together as quickly as humanly possible. So they do have plans in place for some of these things.
Ken, anything different on the transmission side?
Transmission, I mean, it follows a lot of the same avenues, just trying to figure out what the problem is as quickly as possible.
But transmission is going to take precedence.
It's going to take precedence.
Because it's
Yeah.
Regardless
more
of
people.
if there's a transmission line out versus distribution, okay, we'll worry about distribution when we get this in the air.
Yeah, exactly. It's like you're trying to get as many people going again as quick as humanly possible. The one thing that's tricky about transmission is, a lot of the problems are very often much more severe. If you knock over a transmission structure, or you fold the transmission structure in half, the damage can often be much more severe than in a distribution line. I think the degree of I'll say like creativity needs to be there in repair. Utilities work on a set of standards. They're not always able to get standards-based material after a storm quickly. So, they need to be talking to PLP, to their consultants, to their contractors, to say, what can we do, no matter what, to just get this going?
Yeah.
And I've been involved in some pretty interesting conversation with utilities engineers about being like, okay, we can't get X, Y, Z. PLP, can you help us get Q? So we're like, well, I don't know if Q is going to work, but what about ABC, right? Like, and it's crazy because that's some of the most like fun problem solving. It's unfortunate it's around a storm that where people may have been hurt, but still, it's problem solving. And it really makes you feel good when you're like, hey, you know what, that solution is going to work. We can get it to you next day, and we can get that transmission line back online.
Yeah. So creative problem solving. Yeah, love it. So on top of storms, we just talked about the increasing need for more electricity, whether it's for EVs or AI or data centers and all this stuff that's needed. So how can the grid keep up? So we talked about a little bit about building. Is it the HTLS conductors and these advanced conductors? Is that the way?
That's part of it for sure. And I don't think there's really an easy answer to this question because I don't think there's one answer.
I think there's an easy answer, but it's never going to be done. Well,
what's your easy answer?
Just to jump in here, we look at the available generation resources, and way back when I was at First Energy, Ohio Edison, if we had 3% extra capacity at peak, we were doing good back then, and there was a generation crunch then as well. We're even tighter today. The thought process is, and I've mentioned this before, is the distributed energy resources. They're relying on a lot of that. They're relying on battery technology to be what we would call a peaker, meaning when all of a sudden we're above the generation capability, these would come online and backfill coming out of batteries. But, the other big thing is, and this is really way out of our realm, is nuclear, small nuclear distributed energy plants. They're talking, 5 megawatt plants dotting the area. It's a big thing that the groups that I'm dealing with through Neiman, and I'm pretty much on the insulator standards committee. We're insulators. Stupid insulators just hold the conductor up, but there's a lot going on there. But being part of the grid leadership group, that is huge. I mean, we talk about the nuclear front. We talk about distributed energy. We talk about different flows, and it's a lot of stuff really above my pay grade. But it's interesting to see where we are sitting and how our hand into helping reinforce the grid is as important as these other pieces. Because if you don't have the structures, you don't have the conductor, you don't have everything connected from point A to point B in a good fashion, none of this other stuff works.
Yeah. And that's what I was going to kind of get into is like, and you said this to me, right? Like, I don't, like, there's no easy answer because it's everything. Like, these are advanced engineered systems. So really to keep up, I mean, you need to be considering advanced conductor technologies. You need to be considering your insulator design. You need to be creative with your structure design. Because the fact of the matter is, I mean, the rate of build is not keeping up with the projected load rate. Like those right now.
The Texas freeze issue was a perfect example. You know, there was a lot of finger pointing, but it still came down to there wasn't enough interconnection and there wasn't enough transmission.
Yeah. I was at a conference last year down in Texas in September. And you can imagine how hot Texas in September was. It was a very toasty week. And the CEO of Encore, one of the biggest utilities in the country, actually was there, and he let light that basically that day, or the night before he came to the conference, he almost didn't come because they got so close to having to basically black out half the state that they were so close that they had to basically start just dumping load. Like just shutting off certain load areas.
Loads that they agree to shut off.
Yeah, and it was mostly battery.
Yeah,
stuff, backup batteries. Stuff that they would say, okay, we don't need to be loading these right now.
We don't need to be charging.
No,
this
exactly.
Stuff, right?
So, and it's because the heat was so, the heat was so high, and he came and said, like, listen, this is all well and good, and renewables are all well and good, but when it's this hot, windmills aren't working. Well, the wind's not certain.
Well, and that to that point, Texas policy, they put out an edict that they needed people to create fossil fuel generation in Texas to offset this problem.
Yep.
They've got no takers at this point.
Yeah.
Because everybody's afraid to go that route because of the federal policies. So we're in a world of hurt when it comes down to turning generation, because that is the backbone. It's always been the backbone. Solar and wind are good peakers. They cannot support that base load, and that's why I said there is a solution. It's called nuclear, and there are safe nuclear generation types. But again, we got to get through policy. We got to get out of our own way to be able to facilitate that. But we'll see what happens in the next 20 years.
Mm-hmm. Really interesting stuff. So final question. I know you guys got some meetings you got to get to on a Friday afternoon. I don't know who hurt these people, but so transmission, distribution, which is better?
Neither.
Better. No, yeah. I would never have that argument. They're both there.
It's
you need both.
One doesn't work without the other.
Yeah.
Okay.
Because
you guys are pals.
Absolutely.
Right.
Absolutely. Oh, absolutely. Okay. Without when you start looking year to year, sometimes transmission is the king of the hill, bringing in all the money, and then other days, distribution all of a sudden has this groundswell because of storms. Mm-hmm. But what's nice about distribution, it's very methodical. Plot. We know we're going to bring in a certain amount of income because of distribution, because it is there, and because there's so much exposure, and because it needs so much help. They're always working on it. So there's always distribution going on. Transmission, on the other hand, it's real project-based. And policy, again, can really wring out the transmission dollars. So transmission is extremely needed because you can generate as much power as you want. You can't use it without transmission.
Yeah. Yeah, I mean, you could build a transmission line at distribution construction, to go 200 miles at 35 kV. You're not going to have anything at the end of the line because you're going to have lost it all to the environment. But, one can't function without the other. That being said, my stuff is shinier.
It is shinier. Yeah, it is.
Yeah.
Well, great conversation, guys. Thanks so much for being on here. Thanks, guys.
Awesome. Pleasure.
And stay tuned for more Connecting the Lines. Thanks, everybody.
Thanks, everybody.
Thanks.